Alright, in this section, we're going to look at how to solve one-step equations. First, we're going to look at adding and subtracting, and then we'll look at multiplying and dividing. So to start off, as a reminder, an equation is a mathematical sentence with an equal sign. And a solution to that equation is any value that makes an equation true. So if we look at our steps to solve these equations and find the solutions, our first step is to use the opposite operation to isolate the variable. This is also called the inverse. The inverse operation. So opposite or inverse mean the same thing here. Our second step is to simplify the solution, and then our third step is to check our answer to see if it's true. So for number one, let's look at an example. It says solve each equation and check your solutions. So if we look right now, we have a as our variable. We want to isolate a. That means we want to get rid of that plus 15. Well, if we look at step number one, it says use our inverse operation to isolate our variable. The inverse of addition would be subtraction. So I'm going to subtract 15 from both sides. I'm going to draw our line down the middle of our equal sign to keep track of what's happening on both sides. 15 minus 15 is 0, so all I have left on this side is a. Then on this side, 47 minus 15, I need to simplify this to get my solution. 47 minus 15 gives me 32. Now to check, if I plug this back in, if I have 32 plus 15, that gives me 47. And that's what I wanted. Okay, so let's look at number two. I want to isolate my variable r, so I need to get rid of this plus 27. The inverse of addition is subtraction, so I need to subtract 27 on both sides. 27 minus 27 is 0, so I just have r on the left. Now negative 52 minus 27. Be careful with those negative signs. Negative 52 minus 27 would give me negative 79. Let's plug that in, check our answer. Negative 79 plus 27 gives me negative 52. And that's what I wanted. Okay, let's look at number three. I want to isolate my variable a. So to get a by itself, I need to get rid of that negative 19. My inverse of subtraction is addition. So I'm going to add 19 to both sides. Negative 19 plus 19 is 0, so I'm left with a on this side, and I get 64 on the right side. 45 plus 19 gives me 64. Let's plug it in, make sure we got it right. 64 minus 19 does indeed give me 45. Okay, number four. Alright, we're trying to get y by itself here. And this time I've got y minus a negative 12. So before I try to move that 12 to the other side, I know that if I have minus a negative, those two negatives make a positive. So I can rewrite my equation before I start moving anything around. Now I have a positive 12, so if I want to move my positive 12 to the other side, I need to use the inverse, which is subtraction. 12 minus 12 is 0, so I'm left with y. That's what I wanted. Now over here I've got negative 82 minus 12. That gives me negative 94. Let's plug that in. Minus a negative 12, we'll plug it into our original equation just to double check we did everything right. And if we plug this into our calculator, negative 94 minus a negative 12, that does give us negative 82. Okay, last example with addition and subtraction. Now our q's on the other side, but it's still going to be the same process. We want to get rid of that minus 12. So I'm going to add 12 to both sides. (23) plus 12 gives me 35, and negative 12 plus 12 is 0, so all I'm left with is q, and that's what I wanted. I get q is equal to 35. So if I plug that in, I should get 35 minus 12 equals 23. So again, that is true. That's what we wanted. Okay, so now let's look at some examples with multiplication and division. So we just talked about the inverse of addition and subtraction. I'm going to draw our inverse circle up here so we can make sure we are using the right symbols. So the opposite of addition we said was subtraction, and the opposite of multiplication now is division. So anytime I have multiplication in my problem and I need the inverse, I can look across my inverse circle and know to use division. So if we look at number 1 right here, we've got c is our variable. That's what I want to get by itself, and right now that a is right next to it. So if I have 8 times c, that means I need to divide by 8 on both sides. 8 divided by 8 gives me 1, so that gives me 1c left on the left, and then I have 816 divided by 8 on the right. And that gives me 102. Let's check, plug it back in. I've got 8 times 102, and that does give me 816. Number 2, I want to isolate my w, get w by itself. So if I've got negative 12 times w, be careful here, our inverse is not addition since we have a negative sign out here. If we have negative 12 times w, that means I need to divide by a negative 12. Negative 12 divided by negative 12 is 1, so I'm left with 1w on this side, and 60 divided by negative 12 is negative 5. Let's plug it back in and check. Negative 12 times negative 5, type that in, and I get 60. And that is correct. Okay, number 3. Number 3, I want to get y by itself here, and right now it's y divided by 3. So now I'm going the other way on my inverse circle. The opposite of division is multiplication. So if I have divide by 3, I'm going to multiply by 3. 3 divided by 3 is 1, so I'm left with 1y on this side. 14 times 3 gives me 42. Okay, let's plug that in. 42 divided by 3. Plug that into my calculator to check, and I get 14. Another way to look at these problems with k divided by negative 7, we could rewrite this problem. Instead of k divided by negative 7, it would be 1 over negative 7 times k equals 5. This is the same problem right here. So if you don't like dealing with that variable in your fraction, you can change your problem to look like this. So now, another way to solve this problem, we'd have negative 1/7 times k. That means the opposite of multiplication would be division. So I'm going to divide by negative 1/7 on both sides. When I do that, negative 1/7 divided by negative 1/7 is 1, so I'm left with k. And then 5 divided by negative 1/7 gives me negative 35. So when I check, I plug that back in, negative 35 divided by negative 7, that does give me 5. So either way you want to solve those fraction problems works. Last example here at the bottom, we've got actually two more, 5 and 6. Number 5, we've got a fraction again. This time it's 2/3 times x. So if I have multiplication, opposite of multiplication is division, so I'm going to divide by 2/3. Two-thirds divided by 2/3 is 1, so I'm just left with x. And then 12 divided by 2/3 gives me 18. When I plug this back in, I get 2/3 times 18. When I check that, it gives me 12, which is what I wanted. Okay, last example. This time my x is on the other side, but it's still the same process. So if we got negative 7/9 times x, I'm going to divide by negative 7/9. Three-fourths divided by negative 7/9 gives me negative 27/28. And negative 7 divided by negative 7 is 1, so all I'm left with over here is x. So this is my answer. Let's check it to make sure. Negative 7/9 times negative 27/28. That gives me 3/4, which is what I wanted. So that's how we solve our different one-step equations.